Hello, Allied Health. I hope you're doing really great today. We're going to move on to muscular system. And oh, there is a lot to say about this. We have about 600 skeletal muscles, and I'm not going to have you reviewing all of those because that is impossible. We're not going to do that. But this is a funny thing. 12 muscles to smile, 11 muscles to frown. I'd always heard it was the other way around. There were more to frown. Therefore, you should smile. But anyhow, so many muscles, and I will post some diagrams for you to review some of the major ones, but we're not going to go into all the detail that we went into when we did anatomy. So some vocabulary is essential, though. Sometimes we call a cell a fiber. If we call it a muscle fiber, we mean one cell, which is very confusing when you're reading. The sarcolemma is the membrane, and the sarcoplasm is the cytoplasm of a muscle cell. So it kind of comes with its own vocabulary. How to make muscles strong is the first thing I wanted to show you, the sort of anatomy of a muscle, because how is it that a little cell, and you put it together with another cell, gets to be so strong? And the trick is the compartments that it's put into and the fascia. So very important is that they're held together by fascia. Some of you have heard of a lot of fascia because of deep fascia massage and all that. Well, it's a connective tissue that wraps around things. So just imagine if you got one cell and you wrapped it. And then you got bunches of those wrapped cells, and you put them all together and you wrap that. And then you got bunches of bunches. You made lots of those bunches. And then you got those and you wrapped all those. Then you start having a structure that's pretty strong. Okay, so that example that I gave you is, these compartments that we wrap are usually one or more functionally related muscles, because you can't have muscles with different functions wrapped up bundled together. Of course, it has to have a similar function and a nerve and their own blood supply. And deep fascia also has collagen and elastin, which are fibers that are going to allow that extensibility and retraction. So let's look at some of this. So endomysium is that first layer that you would have wrapped around one cell, endo, inside. So a perimysium, let me get myself out of the way again. So one cell around here, one muscle fiber. And then peri, we're going to do it wrapped around many of these fibers that have already individually been wrapped. Okay, so that goes perimysium, do you notice? And then if we've got bunches of these bunches, which are called fascicles, if we put all those together and wrap it around again with epimysium, all of that fascia wrapped around the individual one, around the fascicles, around the muscle itself, are all going to join together into one big tendon. And that is very strong. Orientations of muscles vary, and that you know that the strength and the directional pull is going to matter depending on which is the action that muscle has to do. So I don't want you to learn all these names. It's just the shape of that fascicle, right? The shape of that wrapped region of cells is going to determine the strength and the direction of pull. So these are some examples. Obviously circular around the mouth, around the eye, convergent when you have a big group of muscles all converging onto one spot in the arm. Multi-pennate here is the deltoid, that has muscle all around. It's not a flat sheet. It's coming from lots of directions. So all these different shapes of muscle. Remember that this is a review for you, so you're not memorizing all this. The only quizzes that you have, you can look this up if I were to ask a name of one of these, okay? It's just for you to review. So another thing that we spent a lot of time in anatomy with all of you is attachment of muscles. Attachments, those fascia that become tendons are going to connect to bones, and there's going to be an origin and an insertion, where it begins and where it ends, correct? So We learn those in anatomy. That's something you can look up. Again, it's not something you're going to be memorizing. But as an example, I wanted to just remind you that the origin is a less movable portion of that joint, and also it's more proximal, so more proximal, closer to the midline of the body. And the insertion is more movable and it's more distal, farther away. So we say that when you contract, so if you have the arm and you're contracting, the insertion moves towards the origin. So the farther one away from your midline is going to move towards, closer to the midline one, to the origin. So as an example, I have biceps brachii, and it has actually two origins. And so it's going to originate over here by the scapula and the arm and the humerus, because it has two heads, and it's going to come all the way down and then insert. So the terms, again, I don't need you to be memorizing that, is the coracoid process on the scapula and the supraglenoid tubercle, which comes on here on the humerus. And then the insertion is the radial tuberosity. And why we need that is because if there's muscle pain, muscle damage, we want to know where it's coming from and where it's going to. So very important. Again, it's something you can look up anywhere. Just remember that we're always talking about an origin and insertion. So see now, if this makes sense, that when this arm contracts, when this flexes up like this, then it's coming towards the origin, right? Not towards the insertion. So this bone here is coming up. These are some golden rules of skeletal muscle activity, that most muscles cross at least one joint. Of course, you have to have it cross the joint if it's going to move that skeleton. Different if it's around the eye, then it's different. But most of them cross at least one joint. Mostly typically the bulk of the muscle lies proximally to the joint. So remember with that biceps brachii, most of it was proximal. A little bit of the attachment went over to the distal end. All muscles have at least two attachments, an origin and insertion. Muscles can only pull. Yeah, they can't push. You need two. You need one to flex and a different muscle to extend. One to flex, a different muscle to extend. And during the contraction, the muscle insertion moves then towards the origin, which is what I was saying earlier. Good. Now, skeletal muscles don't act alone. They cooperate. They cooperate with other muscles. So for you going into physical therapy, this is something that you're going to learn really well. So which is the boss is what I call it. Which is the muscle? If there's so many that do similar things, which is the one that's really dictating what gets done? Which is the boss? And it depends. So I'm going to list them for you. The categories: you have the prime mover, which is the one that's really dictating, the synergist, which is the helper, the antagonist, that's doing the opposite, right, to that prime mover, and the fixator, which is just anchoring. It's like, let me hold it there so that things don't get away from us. So we do know that the prime mover provides most of the force, right? Flexion at the elbow, it's actually the brachialis and not the biceps brachii. The brachialis is the one that's providing most of the force. But the synergist, the helper, is the biceps brachii. Okay, it stabilizes, it restricts, it modifies the direction a little bit so that you are not spastically moving your arm. It's very controlled. So let me give you an example. For a sit-up, the prime mover are your abs, your abdominals, and your hip flexors. They're also helping out. And the synergists are going to be your obliques, right? Close to the abs, close to the abdominals. And the rectus femoris on your femur, on your leg, also is helping out. An antagonist opposes the prime mover. So the triceps is the classic example of it opposing the biceps and opposing the brachialis, okay? And it actually, so extending the arm is going to be the triceps. And as it extends, the brachialis is sort of letting go slowly. So it slows that movement down. It's sort of releasing as it goes. So you don't flop, right? When you decide to contract something, you're not flopping. And then the fixator prevents a bone from moving. It also stabilizes that movement. So imagine here, trapezius. We have the trapezius here, and it's anchored, right, on the spine, and it's going to be anchored here in the scapula, okay? So here, see how it's a fixator. It's preventing this scapula from just sliding off, right? It's holding on to it there. Good. So it's some of the terms that are used in the usage of these muscles macroscopically. So here's some other examples that I'm not going to go over with you, but I'm going to leave them on the slides. Side bends, and then I'm going to move on to going small. So we want to look at the molecular level of muscle tissue. This is not Joe muscle. Look at it. That is one cell. That is one cell. It doesn't look like Joe's cell. So it looks very different because it has this orientation that's sort of these parallel strands of something that needs to do something really well, which is contract, right? Muscle has to do that really well. It has to be able to shorten and then release. So its morphology differs from a different cell that's a secretory cell or a cell that's a skin cell. So what is it that is in parallel making up this cell? And they are myofibrils. Remember that word, myofibrils? And each one is made up of a filament or muscle filaments or myofilaments. Okay? Muscle fibrils and muscle filaments. So the filaments are illustrated down here, very small, and this big group here of them is called a myofibril. Here is the cell. If we looked inside, remember that this is one cell, what I'm showing you right now. You know, because it has a nucleus here. It might have extra nucleus. They have more than one nuclei when it's muscle. But inside, all we're seeing are these myofibrils all aligned in parallel like this. And that's really important, again, in how a muscle can shorten, how it can contract. This is a diagram that shows a sarcomere. A sarcomere, if I look inside those myofibrils here, is a repeating pattern. And this is going from this zigzag line to this zigzag line, okay? And that is a sarcomere. That is the unit of contraction. It can actually contract on its own and then influence all the other units that are next to it. Okay, so I'm going to stop this video here, and then the next one we're going to look at how it is that muscle contracts. Thanks, guys.